Hey everybody, this is Rhett. Welcome to Statistics. In this video, we'll look at the relationship between margin of error and sample size. It is important to note that there is less variability among larger samples. By nature, larger samples provide more precise estimates of parameters. Therefore, the margin of error will be smaller if a larger sample is obtained. In confidence intervals, E is the symbol that we use for margin of error. N is the symbol that we use for sample size. As N increases, E decreases. And as N decreases, E increases. When your sample size goes up, margin of error goes down. If your sample size goes down, the margin of error goes up. How does the sample size affect the margin of error in confidence intervals? Recall that the margin of error, E, is the product of standard error, which is based on sample size, and a multiple of the standard error determined by the confidence level. For example, to estimate mu, the population mean, you might use x bar plus or minus E, where E, the margin of error, is the product of a critical value from the standard normal distribution, in other words, a z-score, and the standard error, in this case, the quotient of sigma and the square root of n. Notice in this formula, n is inside a square root and in the denominator of a quotient. As n increases, so does the square root of n. And when the denominator increases, the quotient, or standard error, decreases. So a larger value of n results in a smaller standard error. And a smaller standard error, in turn, produces a smaller margin of error. Let's look at a couple of examples. First, on the left, we're using a critical value z of 2. Sigma, the population standard deviation, is 24, and the sample size n is 36. In this example, the margin of error is 2 times the quotient of 24 and the square root of 36. The square root of 36 is 6, 24 divided by 6 is 4, and 2 times 4 is 8. So the margin of error is 8. In the example on the right, we see the same critical value of z, 2, the same population standard deviation, sigma, which is 24, but the sample size has increased to 100. To calculate E, the margin of error, we multiply 2 by the quotient of 24 and the square root of 100. The square root of 100 is 10. 24 divided by 10 is 2.4, and 2 times 2.4 is 4.8. So our sample size increased from 36 to 100, and the margin of error decreased from 8 to 4.8. What if you had a particular goal for margin of error, say 5? What's the appropriate sample size? To answer this question, we need to calculate the minimum sample size requirement. Let's consider a z-interval that estimates the population mean. In that case, the sample size n for a z-interval that estimates the population mean mu to within a margin of error E with confidence level C is given by n equals the corresponding critical value of z times standard deviation divided by margin of error squared. The last step is to round up to the next integer. Here's an example. Our goal margin of error is 5. Our critical value of z is 2. The population standard deviation is 24. On the right-hand side, these values are placed in the formula. 2 times 24 is 48. 48 divided by 5 is 9.6. 9.6 squared is 92.16. We round up to the next integer, 93. So the minimum sample size required to achieve a margin of error of plus or minus 5 is 93. So an increase in sample size results in a decrease in the margin of error. Thank you for watching and have a great day. Until next time, stay real and be rational.